Hello friends, my name is Chirag and we are presenting a project on study of facial key point detection. The objective of this project is to predict key points positions on face images. Given an image, the algorithm should be able to recognize important key points, that is feature of the face. Detecting facial key points is a very challenging problem. Facial features vary greatly from one individual to another, and even for a single individual, there is a large amount of variation due to 3D pose, size, position, viewing angle, and illuminating conditions. Let's talk about the applications. Applications in the real world could be tracking faces in images and videos, analyzing facial expressions, detecting dysmorphic facial signs for medical diagnosis. The data used in this project was taken from Kaggle. There are 15 each predicted key point is specified by an XY real valued pair in real space of pixel indices. There are 15 key points. The input image is given in the last field of the data files and consists of a list of pixels ordered by a row as integers in 0 to 255. The images are 96 into 96 pixels. So there were two data files in this project. So one was training.csv. Training dataset contains images data along with x and y coordinates of 15 facial key points. Other file was testing.csv. Testing dataset contains the images for which x and y coordinates of 15 facial key points are to be predicted. On carefully analyzing the data, we found out that there were fields with missing values, null values, and invalid values. So to encounter this, we used mice imputation, which is a predictive means matching method used for imputation of missing values. Passive imputation used to maintain consistency between variables. The training data in the dataset was very limited. We increased the training dataset by implementing following two techniques: rotate the image and flip image. This gives us more rows in our training dataset and hence can be effective in increasing the effectiveness of our algorithm. So we have implemented these six algorithms, out of which the first average patch algorithm. Now we use the information about the intensity of each pixel to identify the key point. We compute means of coordinates of each of key points in the training set and we use it as a prediction for all the images. This algorithm was very simplistic and it was giving us a very high RMSE score. So to overcome it, we extracted a patch around the key point in each image and averaged the results of the patch. Now with this patch is used as a mask to search for key point in test images. We decide the optimum size of the patch to get good results. Second algorithm that we implemented is deep learning. We used three different approaches in deep learning to get the best score for our algorithm. The first approach is single dataset approach. We used an H2O package library and we created 30 models of all 30 coordinates, that is 15 key points into 2 coordinates x and y for each, which gives us 30 in total. Now based on these models, we use these models as to predict our results in the test dataset. The second approach we followed is like translating the image into 48 by 48. So we translated 96 into 96 images to 48 into 48 images. By using this models, predictions on testing data can be made in H2O. Now because of this, the timing was there was no much significance in the output, whereas the computation time was drastically reduced. The next approach that we followed was two dataset approach. On carefully examining the data, we found out that the dataset can be divided into two different categories. The one which has 30 variables and the other which has only 8 variables. We performed training on these datasets separately and used these models as a base to predict our scores in the testing database. Thank you.
Hello friends, my name is Dhruv and I am covering the next algorithms. Now let's talk about neural network. So it is beautifully biologically inspired programming paradigm which enables a computer to learn from the observational data like humans. In this algorithm, we are dividing the data to create a separate model for predicting only the particular key point values such as a nose, left eye center, right eye center, etc. key points in the test data. And due to its massively parallel nature, neural network requires higher memory and resources of the machine. So there is a need to parallelize the performance of the algorithm to achieve better results. And to do so, we have verified different parallelize operations to achieve the better performance. And by implementing this algorithm, we knew that it provides better result because of its convolutional property. Now let's talk about random forest algorithm. The basic philosophy is it is used to average noise and unbiased models to create a model with lower variance. So random forest works as a large collection of decorrelated decision trees. And first of all, we are creating the random subsets of features, and then we will generate different decision trees for making our class prediction. And depending on the predictor values of all these decision trees, we are going to conduct a voting for the observations of the trees to decide the result, which is the most voted prediction, and it is expected to be more close to the correct results. This algorithm has two major beliefs. First is most of the trees can provide correct prediction, and second is trees are going to make mistakes at different places. So these two beliefs are making this algorithm more correct in terms of result and performance. Here is some visualization of H2O frame interface, which is showing one of the models scoring history and deviance in respect to epochs. So we can see that with increase in epochs, we are reducing the deviance in the training as well as testing data. The second visualization we can see in H2O framework is the outputs and the error values of the prediction models. We have different prediction models for each key point, so we can see and verify the RMSE values and different error values and deviance values of the models. Here are the summary of the different RMS results of algorithms. So as we can see, the average patch being the very basic algorithm as for the starters, it gives a fairly large amount of RMSE that is considered as standard value. But going with the different algorithms like neural network, random forest, and deep learning, we're able to reduce the overall RMSE value, and we are able to predict the better result from for the test data. Now talking about evaluation, so these are the things that worked well, and going with very basic algorithms such as average patching, we didn't get a good performance. So we decided to go with trying out some different algorithms, and with trying different algorithms such as neural network, random forest, and different variations of deep learning algorithms, we are gradually getting the good results for the test data, and it gradually reduced the RMSE value for the test predictions. And since we needed to get the parallelized operations to overcome the performance issue, we actually went through different options and came up with some library packages which worked well on reducing the overall computation time and managing the resources carefully. Some of the things which didn't work well are system crashes during the program execution. The programs were taking high memory and high CPU usages, and the computation time was very large for some programs, ranging from 3 to 4 hours for correctly computing the results. And due to this, we faced some issues like system was freezing for some operations, and this was overcome by using the parallelized packages and operations during the programs. Finally, going through the conclusion is uh, first we found out that images translate to 48 cross 48. That means half to the size of the original size. Takes very much lesser time to compute without affecting the efficiency of the algorithm at a much extent. And second is deep learning algorithms with dynamic modeling with two data sets approach gives us the best results among the given algorithms models. Third one is, since this all process is time consuming and resource hungry, parallelization reduces the computing time at a greater extent. We would like to thank Professor and teaching assistant for providing constant support and guidance throughout the project. And if you have any questions, you can reach out to us. Thank you.